Okay, here we go. 11.2, simplifying rational expressions. Yesterday, or 12.2. Yesterday we talked about what a rational function is, and it's when you have a polynomial over a polynomial, and you have an x in the denominator. Okay, so all of these are rational expressions. Here on the first one we have a monomial over a monomial, a binomial over a binomial, a binomial over a trinomial. Now, just like any fraction, because it is like a fraction with variables in it, we can always reduce the fraction. So when we had something like 12 over 20 over 28, we could reduce both of these by 4 and say that it's 3/7, right? Because this is 4 times 3 and this is 4 times 7, and we reduced. We factored it, then we reduced. But we don't always show all of our factoring, but that's the principle behind it. So on here, when we're simplifying a rational expression, you must factor first. Huge, 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 and then reduce and cancel. And how do we factor? We have, what methods of factoring do we have? Okay, GCF. What else? Diamond and modified diamond. What else? Difference of squares. And then we have grouping, but that doesn't happen very often. That's with your 4 terms. Okay, so now on here, right now, and please listen, don't be starting off on this. This is a sum. Up in the numerator, it's a 6x plus a 12. It's a binomial. This is a sum. Before you cancel, you have to make it a product. And how do you make it a product? You factor it. So Hazim, how would I factor this one? The numerator. How do you factor 6x plus 12? What? Okay, and what would you do?
Take out x plus
No. Yeah, Zach?
Take out a 6.
You take out a 6 first. And you have x plus 2, and you have x plus 2. You have now made it a multiplication problem. You cannot just cancel 6x and x, and you were saying 5x. No. There's work to be done. They aren't all that easy. You have to make it a product. Something times something, just like we did up here. We didn't just go cancel the 2's because it's the same digit. That's basically what you're doing if you cancel the 6x and the x. You have to make it a product. So this cancels, and your answer is just 6. Okay? Sasha, now, is this a sum or a product up here? It's a product. So guess what, you guys? You get to just cancel right away. It's already factored. It's 15 times x. It's 25 times x squared. So what could I cancel it to? What could I reduce it to?
3 over 5x.
Okay, very good. 3 over 5x. And if you don't see that, you can factor it just like what we did before, and you can cancel this, and we know our rules of exponents. That's coming back to you from chapter 8. There's your answer. I didn't have to factor it because it wasn't a binomial or anything. Now, Matthew, can I just cancel the 12 and the 3? No, because this is a sum. It's a binomial. How can I factor that down there? Take out a 3, and what would I have? Now, can I reduce anything? What? 12 and 3, because this is 3 times 4 times x squared. You can cancel this, and what would your answer be? Can I cancel the x's? No, it's not 2 times x, it's a sum. If it's a sum or difference, you can't just take one of the terms and cancel it. No, no, no. So, there are things that you have to do before that. Elliot, what would you do on number 4?
GCF
Okay, very good. And what would you have?
would be two
Okay, 2x
minus
minus 1 all over 2x minus 1. Now can I cancel something?
1. Yeah. Would be
Since the binomial is exactly the same, you can take off the whole binomial, okay? But over here, you can't just take out the 4 and the 2 because x plus 2 has to be all together. So your answer is just 2. Excellent. Oscar, what would you do on number 5?
GCF.
Okay, and what would you have?
You have 2.
There's a bigger number. What else goes into 20 and 4? Doesn't 4 go into 20? Huh? So what would be your GCF? What do 20 and 4 have in common? 4. You said 4 goes into 20, right? How many times? And 4 goes into 4, doesn't it? So what am I going to take out of the parentheses? What am I going to put out here? The GCF is then a 4. And what are you going to put inside the parentheses? And plus what? T. And down here I have, now, are these the same thing? Is addition commutative?
Yes.
Yeah, you can change. 2 plus 3 equals 3 plus 2, t plus 5 equals 5 plus 2. Does it work in subtraction?
No.
No, and we're going to learn that later, so don't be working on your homework. So what can I remove now, Oscar?
The 5 plus D.
Okay, and your answer will just be 4. Okay, Jake, what would you do on number 6?
First on the top, I would take out the 2 to make it 2 parentheses x minus 6.
Excellent. And then what would you do?
Do over parentheses, x minus 6, other parentheses, x minus 1.
Because he did the diamond, and maybe you don't need to do the diamond right now, but that's okay. Okay, but if you did,
Then you can take out the x minus 6.
and your final answer would be?
2 over x minus 1.
Very good. Darren, what would you do on number 7?
Find the GCF.
And what would that be?
3.
That would be a 3, and what would we have then inside the parentheses?
X plus 4.
And down here,
Use the diamond.
okay, you'd have negative 20 and a negative 1, and what would I have then?
4 and negative 5.
Very good. And so it would be,
X plus 4 times x minus 5.
okay, and then what can I remove?
X plus 4.
Okay, so if you didn't get factoring and the diamond before, you've had since chapter 7 we've been doing it. So now we're up to chapter 12. So hopefully by now you've got it mastered. Yeah,
And your number.
sure. Armand?
Well, so you have to do GCF.
Okay, and what would you have?
2 x, that's one outside parentheses, x minus 1. And then you have to do the diamond on the bottom, which you get 3 over 3 at the top and then negative 4 on the bottom.
Mm-hmm.
And it would be 3, negative 3, no, negative 1, 3,
Negative 1, negative 3.
yeah, negative 1, negative 3.
So your two factors would be?
x minus 1, x plus 3, and
No, it'd have to be minus 3.
minus 3.
Because the product has to be a positive, so you have to have a negative times the negative.
Oh, okay.
And the sum is negative. So what can I remove?
You can remove the x minus 1 from the top and the bottom. And you get 2 over x minus 3.
Very good. Okay, Adam, what would you do for number 9?
You factor the top, 8 parentheses plus 2.
Okay.
And then you do diamond, you get parentheses 2x plus 1 and x plus 2.
Very good, because you'd have to do the modified diamond. Remember, those of you, a lot of you on the last test on chapter 10 forgot to put the 2 on the top of the dashed line. Don't forget that now. You have an opportunity to show me that you know that better. So he said 2x plus 1 and x plus 2, and now what?
You reduce, you get 8 over 2x plus
Can I cancel the 8 and the 2?
1.
No, I have to have exactly 2x plus 1. Okay, number 10. Number 11, you're going to see a twist. He1, what'd you get for number 10? Good. And so what could I cancel? What do you get? And so many people, very good, and you're done. Want to cancel the x's, want to cancel the negative 3's, and say my answer is negative 1. The only time that would ever occur is if it was negative 3x over 3x. Because that's all factors. This can cancel, and you end up with negative 1. Okay? Okay, Annika, on this one, what would you have?
First I would, on the top, I would...
Watch, you're going to learn something, everybody, that thinks they know everything already. Yeah, what would you?
Take out a 5.
Good.
So 5 times x minus 3.
Okay. Jordan, come on. And then how am I going to factor the bottom?
Difference is squared.
Very good, and what would that be?
That would be 3 x minus 3. Or is it 3 minus x plus 3%?
Right, because it is not commutative. This, you guys, now just watch. X squared minus 9 is x plus 3, x minus 3. 9 minus x squared is 3 plus x and 3 minus x. Now, we've got a problem, don't we? There's nothing the same. However, with this, what I could do is I could change this around by taking out a negative 1. Isn't this equivalent to that? Because a negative x times x is negative x. A negative 1 times a negative 3 is a positive 3. These are the same thing. So I could actually write this. I'm going in lots of little baby steps here. You won't always have to, but for you to understand it. It's really like this. This is the same thing as this. I switched it by taking the opposite. Okay, now you can cancel it, and you would have 5 over negative 3 plus x. You never leave your negative in the denominator. I would make it a negative 5, and I'm going to just write it as x plus 3. That looks cleaner than 3 plus x. You can do that with addition. So basically what I'm saying is, and watch this so that you understand why. If you understand why, you'll remember it more. If I have 5 minus 2 over 2 minus 5, that is 3 over negative 3. Isn't that equal to negative 1? If I have 7 minus 10 over 10 minus 7, isn't that equal to negative 1? So if I have x minus 5 over 5 minus x, what would that be equal to? Negative 1. So on here in this problem, we had 5x minus 3 over 3 minus x times 3 plus x. Right here, I would know that this equals negative 1. You don't have to go through all that jazz. Now, don't get confused that this over this is negative 1. This does not equal negative 1. You cannot cancel. Okay, so don't make that boo-boo. Okay, if you had x minus 3 over 3 minus x, that equals negative 1. Because 1 minus 3 over 3 minus 1 would be negative 2 over 2, which is negative 1. So, learning that, J. Lee, what would number 12 be equal to?
X, X minus 1.
What's your answer then? What did I just say? All of these are equal to? Your answer is just negative 1. Why? Because if you wanted to, you could have taken out a negative 1 here and have x minus 4. Cancel, cancel, and you'd have 1 over negative 1, which is negative 1. Okay, but you don't have to go through all that anymore, right? Do you understand why it's like that? Okay, Taylor, how would you do 13?
You can solve the bottom with 5 and 6 squares.
Okay, you're correct. What would that be?
It would be x plus, x plus 8 minus x minus 8.
Okay. And then what would you do?
And then,
What does this equal right here? Negative 1. So I can cancel this out and say it's negative 1 over x plus 8. Okay? Got it?
Yeah.
Okay, Michael D., before he falls asleep, how do you do this one?
Use GCF,
Okay, and what do you get?
x squared minus 1 over 1 minus x squared.
Did you take a 3 out?
Yeah.
Then what?
You get x squared minus 1 over 1 minus x squared,
And what's that equal to?
negative 1.
That's equal to negative 1. You didn't even have to factor it to x plus 1, x minus 1. You can cancel the whole thing, so what's my final answer? No, you have the 2 and the 3. Negative 2 over 3. But the negative with the numerator. Are we good?
Yep.
Do we need to do more?
Nope.
Okay.